Hey, James at Barber Creek Long Range Shooting School. We're gonna hit Spindrift and Coriolis one more time. So I'm running the Eagle Ballistics app and it's telling us to dial 30.5 minutes, and that's where we're at. And I got a 0 wind speed because there's no wind out there right now. And what I'm gonna do is I'm gonna shoot it at 1,000 yards at the clay pigeon, and I wanna show you something. So give me 1 second, let me shoot one round. I have the long range camera on there. Let me double check and make sure there's no wind. There's no wind. So I'm going to shoot at the clay pigeon under target number 2. And you can see we went about 10 inches to the right. Now, if I go to Eagle Ballistics and I go to the range card, there's a area and range card called detail. So Eagle Ballistics was designed as a training app for my class. Again, it was really never supposed to be sold. But bottom line is all my students wanted it, so we had to find a way to get to it. But it breaks down the entire flight path of the projectile, because again, it was a training app. And if you look in the horizontal offset, I've got 0 wind. It's telling us that we have 7.93 inches of Spindrift and 2.12 inches of Coriolis. In the northern hemisphere, Coriolis is going to be to the right. Reality is it's only 2 inches or less than a quarter minute of error, but when you add it together with the Spindrift, you're talking 10 inches of miss at 1,000 yards. And this bullet is nothing special, it's just a standard Creedmoor. I got a chronograph, we got a velocity of 2673, and you can see that our bullet is rotating at 240,000 RPMs. And it's got a gyroscopic stability of 1.7. So because of that spin of a 240,000 RPMs, the bullet is drifting to the right. So I'm not going to get into the technical of how it's doing yaw, repose, and all that, but just realize if you're shooting at an object in no wind, at basically any distance, the bullet is slowly drifting to the right with the right-hand twist. This is an 8-twist, right-hand twist, 6.5 Creedmoor. So now what I'm going to do is I just shot at it and I just went to the right about 10 inches. What I'm going to do is listen to the app. The app is saying, hey, you need to push left 0.9. So let's do that. So Eagle Ballistics is compensating for the earth base effects and secondary effects. So in other words, it's going to compensate the Spindrift, compensate the Coriolis, and say you need to push left and no wind. Let's do that. Sand clay pigeon under target 2. I'm pushing left 1 minute. And broken clay. So as you can see, with a good ballistic solver that calculates the earth base effects and Spindrift, you're going to be able to make a good shot. Now let's do it at a little closer range. Let's just say we're going to shoot, I don't know, 600 yards. So at 600 yards, it says we need to push left half a minute. So if you guys stand by, I'm going to go ahead and jump on the camera, and I'll be right back and get it on the 600-yard target. All right, I have the camera on 700 yards because I was going to do the 600, but it's all shot up from yesterday. So let's go ahead and go to 700 yards. We're at 17 minutes, and it's telling us to push left half. Let's go ahead and do that. Target number 2, level looks good. No wind still. Okay, perfect elevation. I'm sorry, perfect wind left and right, just above the dot. Now I'm going to shoot it at no wind. And it looks like we went about 4 or 5 inches to the right. Let me look through this rifle scope. Yes, right at half a minute. So in Eagle Ballistics, if I go to the range card and I go to details, it says we have 3.4 inches of Spindrift at 700 yards, and we have basically 1 inch of Coriolis, or 0.95. So altogether, we drifted right 4.39 inches, and that's about exactly what I'm seeing there. So does it really matter for Spindrift and Coriolis? At close range, not necessarily. You know, to me, I consider anything under 600 yards close range. You start getting out further where everything starts to matter because it's based on flight time. At 700 yards, we're 0.96 seconds of flight time. You know, if we're shooting 300 yards, we've only got 0.3 seconds of flight time. But bottom line, 600 yards is kind of where everything starts to come into play, where earth-based effects, secondary effects, spindrift, Coriolis, pressure, temperature, all that really starts to take a play on your projectile. So keep that in mind when you're shooting long range or even medium range, that if you run a good ballistic program like Eagle Ballistics, and there's others out there too, of course, it will compensate that spindrift and Coriolis, the earth-based effects. But bottom line is, it matters to me, anything past 600 yards is where spindrift is going to start to bite you, and Coriolis. Again, at 1,000 yards, it's 10 inches-ish with this gun. It could be different with yours. And at extreme ranges, just to give you an idea, at the ranges we shoot on a level 2, let's say we're shooting 1,602 yards, it's going to be, let's go to our details. You've got 28 inches of spindrift and 6.86 inches of Coriolis, which means you would have completely missed a target by 35 inches in a no-wind situation. So I want to bring that back and kind of explain something to you as well. I know I mentioned this before, and then I'll get off the film. Wind is not linear. In the old days, when you printed up a range card or a wind card, you know, and you would have it taped to the side of your stock, and it would say, okay, I set it for 10-mile-an-hour wind. It says, you know, 1 mil or 2 minutes of wind, 3 minutes of wind, 4 minutes wind. Wind is not linear. Your spindrift and Coriolis is added to a left-hand wind. Your spin and Coriolis will compensate or delete quite a bit of a right-hand wind. For instance, if I was shooting at just 1,000 yards, we'll make it a semi-close shot, and the wind was 2 mile an hour, you can see that I only have to push right a half a minute. Let's say that the wind was 1.5 mile an hour. Really, it's a dead-on shot because our spindrift and Coriolis went to the right 10 inches. The 1.5 mile an hour wind pushed it right back into the target. Now let's make it a 9 o'clock wind at the same velocity. You can see we have to push left 2 minutes, right? Because the spindrift and Coriolis is added to that left wind. All right, hopefully this makes sense. You guys have a great day. I got to get ready for class, and we'll talk to you later.